This is SmartNICs Today. I'm with Lukas Sismis and Korenek, and we're going to talk about how to improve IDS performance, the use of FPGA-based NICs. Lukas, why don't you take a moment and introduce yourself, and then we'll go to Jan.
Thank you, Scott. So hello, everyone. My name is Lukas, and I'm in the IDS domain for over 6 years now. I partly got in thanks to academia, thanks to my master thesis, but since then I've also taken industry expertise from there. I'm member of Suricata team and also DYNANIC member, where I specialize in integrating Suricata IDS with the FPGA offloads that the card offers. Thank you.
And Jan?
Okay, hello everyone, I'm Korenek. I have more than 20 years experience in high-speed networking and in, let's say, using FPGAs for processing network traffic and some background in the network security. Currently, I am a Chief Strategic Officer at DYNANIC.
Awesome. Why don't we just jump right into it? Lukas, the open source applications like Snort, Bro, and Suricata have been around for quite some time, processing gigabit Ethernet, and obviously gigabit Ethernet's evolved to 10 gig, and now we're moving to 25 and 100 and 400 beyond that. Server core counts obviously aren't scaling as quickly as Ethernet has been scaling over the last decade. So is this kind of an accurate assessment of where we're at and, some of the problems we're going to face?
Yeah, that's correct. So in the early days, one CPU core to process all the traffic was enough. That's how the systems were built. That's how Snort or Bro was built. It was a single process, single core application. And as the network scale, applications had to adapt. So they used more cores. They often relied on the CPU clock frequency increasing, and they, at the time, relied on the increasing CPU core count. But as the 100 gigs, and then later on, nowadays, 400 gigabits is incoming. Problem is more and more apparent because a few years ago we essentially got capped with the CPU clock frequency, and the CPU core count does not increase at the same pace as the network links increase. So that's why we are essentially facing this scalability problem, and why we need to think of new approaches to this domain.
So given that problem and the fact that the core counts aren't scaling as quickly, the natural inclination of infrastructure builders is to facilitate 100, 400 gigabit Ethernet to obviously scale up their architectures by adding more boxes and more resources to handle the volume. Is that kind of a fair assessment of how the industry's been responding to this?
Yeah, definitely. You need to increase the amount of the servers for processing the traffic. So this is an issue because you need to also distribute the network traffic among the CPUs, among the servers. And it's also one complication for reprocessing. And it's expensive because you have many servers. You have also some load balancers that has to distribute the traffic. So it's very expensive. Not so easily to scale to such speed using a standard server approach.
So then the obvious solution would be to look towards optimizing the software stack or the packet processing pipeline, right, to remove any hotspots and kind of tighten things up and remove the limitations around how many packets per second each core can handle. What is your view on that, and what kinds of things have been done?
Sure. So I can personally say it from my Suricata perspective. When I'm deploying the Suricata sensors, I'm specifically focusing on few areas. Of course, it's a valid configuration of the sensors. So putting reasonable amounts of flow memory, let's say for flow processing or reassembly, then picking out the correct capture mode or capture interface. Recent innovations in the kernel space has moved this barrier down to minimal, but the capture mode is still there. And that's why when you want to go with high network packet processing, you still want to reach for, let's say, a DPDK, data plane development kit frameworks, which are highly optimized for that high throughput applications. Then when you want to optimize the deployment, you want to evaluate how your hardware setup is configured in a sense let's say, if your memory channels are fully occupied, if the CPU affinity and NIC queue load balancing is all correctly set up. And we can also mention from the operation side also the rule set profiling. So whenever you are, deploying new rules or creating them, you want to actually write the highly efficient rules, not just rules that work, but you need to think like that application to really leverage that high performance potential and to not be that blocker. So from like the application side, the applications like Suricata, Snort have adopted different techniques like faster pattern matching algorithms or some capture bypass mechanisms to aid with the processing to be really highly optimized.
So if we look at this, where are applications like Suricata spending most of their CPU cycles, and can we tighten up these areas and improve them further?
It can be various, but the main hotspot is really consistent. It's the pattern matching. It's when since the IDS rules contain a lot of static patterns which are searched in the traffic. This is a highly complex task. So far is done only in the software. That's why these applications try to employ new algorithms like Hyperscan to boost that throughput. But other than that, other parts of these applications include, as mentioned, the packet acquisition mode or capture mode, stream reassembly, or the remaining detection logic.
When it comes to optimizing Suricata execution, what have others done in the industry? What's already been tried? Are we kind of exhausting the limits of what's not to turn?
Well, I don't think so. There are couple different directions from different vendors or different organizations that want to optimize the IDS throughput. One obvious thing is that pattern matching. I think on the CPU side, we are very close to the limits. Hyperscan or currently a VectorScan is using highly optimized CPU instruction sets to be as fast as possible, but we can still look for ways how to move it into the hardware. Pattern matching is one thing, then the others, like in Apotec, they are using the FPGA SmartNICs to offload certain traffic processing. So if, let's say, Suricata thinks that certain traffic is not really valuable to inspect, it can control the SmartNIC to filter it out directly on the SmartNIC level. This way, the card itself saves PCIe bandwidth and also saves the CPU cycles that need to essentially look at the packet and decode it to find out that it should be dropped out on the SmartNIC level.
Right. So essentially you put it in the flow table so that the FPGA is filtering it early in the pipeline. The data doesn't have to come up to the host CPU.
Yeah, exactly. This way it's much more optimal. The advanced solutions use even connection tracking tables so that you have full visibility even though you offload particular connection to the SmartNIC. You can still query the statistics and see if the flow is active, when it's finished, or scenarios like this.
So my understanding is that DYNANIC is a slightly different approach and that you guys are focusing on accelerating some of the pipeline hotspots. How does that actually happen? What are you actually doing?
At the DYNANIC, we don't have only the flow tables for the prefiltering the traffic and decrease the load to the CPU. We also support the pattern matching in the hardware, which is, let's say, the acceleration of the most time-critical part of the IDS system, as mentioned by Lukas. So this is the big advantage. And maybe, Lukas, you can explain that how it works in such a way that there is not everything processed in the hardware, but it's a very nice cooperation between the software part of the Suricata, of the IDS, and the hardware part in the FPGA SmartNIC. Because if you look just on the part of the processing and you implement everything in the FPGA SmartNIC, it's not so efficient, because as things are changing very fast, you need to adapt the functionality. And if you have everything implemented in the hardware, it's very difficult to keep up. So it's very important to have a good design and well-designed to split the functionality between the hardware and software, provide the intelligence in the software and the processing, which is time critical in the hardware. So we have designed in such a way that there is, of course, the flow level tables and processing and in the hardware, and together with that some pattern matching, but it's integrated in such a way that it cooperates very well with the Suricata. So it works in such a way. Maybe Lukas, you can a little bit more in detail describe how it works.
So you've got kind of a grep in hardware.
That's correct. It's actually hardware software co-design. As Jan mentioned, we didn't want to re-implement the full pattern matching pipeline in the hardware itself, because it would have limitations, not only the ones that mentioned Jan, but also there are hardware limitations, like the resources at the hardware level are constrained, and you need to be really considered to what functions to offload to the SmartNIC itself. So what we did at DYNANIC is that we are offloading pattern matching part, but only for the packet payloads only, so that Suricata can still do whatever it wants with regards to the TCP reassembly, with regards to the application layer processing. It's essentially, free metadata passed to Suricata or to any application basically, and it may then decide whether it wants to use those matched patterns or not. In the case of Suricata, if it detects matched patterns in the packet itself, it skips the multi-pattern matching part of Suricata in the packet payloads and just reuses the patterns found by the hardware itself. So that's how we offloaded the hottest spot of the IDS to the hardware. That Suricata then does the full TCP reassembling and application layer parsing, and later applies multi-pattern matching to at the L7 layer or wherever it needs to complete the full detection. This way, we essentially didn't need to modify Suricata heavily. It was just a minor modification, but we also delivered the highest possible offload in a very easy manner. We also added flow offload to Suricata as well. So we added this functionality on the DPDK level, and the benefit of this approach is that you get vendor neutral solution that's compatible with SmartNICs from NVIDIA, DYNANIC, other vendors as well. At the same time, it supports connection tracking tables and delivers the extra throughput improvement, as in the case of, let's say, Napatech or other hardware NICs.
So in other words, this increased flexibility allows you to deploy across a wider variety of platforms.
Yeah, exactly, because DPDK is available on multiple platforms. So I think that this way, the connection to Suricata is for many vendors, not just for the DYNANIC.
Do you want to take a moment to summarize the 5 key things that you've done within DYNANIC to improve overall Suricata performance?
Okay, so first of all, it supports a flow level processing. So the decrease based on the connection tracking decrease the network traffic that is go to CPUs. So it's control the flow level processing by the Suricata. This is one key thing. And another key thing is to acceleration of the multi-pattern matching, which is the core most time critical part of IDS system. But it is not running completely in the hardware. It's just a pre-processing with the results that's provided to Suricata, and Suricata will utilize the results to skip the functions that consumes the most of the the most of the time complex task. So these are the key functionality, and of course it's based on the DYNANIC platform, which provides full packet capture. It provides other functionality that helps for the processing. So this is the key things that helps to IDS and to the Suricata from the DYNANIC side.
Lukas or Jan, do you got a few other final words you want to say to kind of summarize things, wrap it all up?
What we are doing is to provide the acceleration for this cybersecurity IDS solution that is high performance, so it can scale to 100 gig per second, 400 gig per second, and is also adaptable because we utilize the FPGA technology, which is configurable. We provide an adaptability, so as the Suricata is evolved, as the IDS is evolved, and any cybersecurity, any application is evolving, we can evolve the functionality as well. So which is a big advantage that helps to keep up with ever-evolving cyber threats, not only at the software level, but also at the hardware level, which I think is very important, especially in nowadays. So this is very, very important. And this is important especially for the IDS, because as we mentioned, the per-core performance for the IDS is less than 1 gigabit. It's even, let's say, 0.5 gig per second for the Suricata. So the scaling by the CPU cores is difficult, and you need some kind of the hardware, and the answer could be the SmartNICs. And if we want to evolve the functionality over the time, the FPGA SmartNICs is a very good answer for these limitations.
Correct. I may only disagree with Jan. I when I started working with DYNANIC, it's really appreciative that SmartNICs, the ASIC SmartNICs from nowadays, could only support, let's say, the DPDK flow. Nothing like accelerating, pattern matching inline would be possible with the ASIC SmartNICs. But with FPGAs, as they can basically adapt to new functionalities, new protocols, or anything that needs to be customized, you are basically free to do whatever you need to do, as long as it fits the constraints of your solution and the solution of the DYNANIC. So yeah, that's a great way forward for me.
Excellent. Well, thank you guys for your time today. Really appreciate it. I believe you've helped a lot of people understand more about IDSs and how to improve IDS performance by using an FPGA, Suricata, and DYNANIC. And for any questions, I'll put the link in the description for podcasts so people can follow up with you guys directly. I also understand you're going to be at Black Hat for a week or so. Do you want to tell us about that, Jan, or who's going out?
So we will be at Black Hat. We will be directly in booth, so we would be very happy if you could stop by and follow up on this podcast. But we will be showcasing this discussed solution live on the Black Hat floor. We will have with us the 400 gigabits FPGA card with us that will be deployed directly in the server, and on that we will be showcasing the demo of this co-designed solution for Suricata. So yeah, we would be just happy to follow up with anyone that stops by.
So you guys are going to be in booth 6215, and that's August 5th and 6th, if I'm not mistaken.
That's correct. And
everyone is welcome to come to our stand, and we will present the demo and show how it works live.
Well, I will see you there.
Thank you, Scott.
Thank you guys for your time today. This has been SmartNICs Today, and we appreciate you guys listening. Thanks for your time.